Hello students, welcome back to my channel NJ Math World. Today we are going to discuss about BCA first semester SCP discrete mathematical structure, computational discrete mathematical structure, relation and function chapter, important exam questions. So here we have first question is defined relation and function, which was asked in the previous year question paper, January 2025. It was for 2 mark. So what is relation? A relation R between two set A and B is a subset of Cartesian product A cross B. So if A is 1 2, B is 3 4, a relation can be written as R equals 1 comma 3 and 2 comma 4. Then what is mean by function? What is a function? A function is a type of special type of relation where each element in A maps to exactly one element in B. For example, f of x is square. Then the next question is write any two types of functions, which was asked in the previous year, Jan 2025, for 2 mark. So what is 1 1? 1 1 function is also called as injective. Each element in the domain maps to a unique element in the codomain. And every or we can write this otherwise we can write this for this definition. Every element of domain should have one and only one image in the codomain. Then also it is called as one to one or injective. What will be the example for injective? It is here each element of domain. This is called domain. Each element of domain is mapped to each element of codomain. So it is called as 1 1 function. What is
Then
onto function? Onto function is also called surjective. What is surjective? Every element in the codomain has at least one pre-image in the domain. So every element in the codomain should have one pre-image. It should have B has one pre-image. C has one pre-image and two pre-image. It should have at least one. It means it can have one and it can have two also. It can have three also. So every element of codomain should have at least one pre-image in the domain. Then it is called onto function. So here you can see there is for B there is no pre-image, therefore it is not onto. Then the next question is let f of x equals x plus 2 and g of x equals 2x plus 1. Find fog x and gof x. That was asked in the last year question paper 2025. So what is fog and gof? So here we'll just cite fog, fog of x. What is fog of x? Fog of x is f of, this of means it's bracket, g of x. So now we'll write f of, what is g of x formula? We have it is 2x plus 1. Now write down what is f of x. F of x is, because we have f here, so write f of x. F of x is x plus 2. Call this as equation 1. Now compare this x with the value which is there with x in the previous line. So we have x is equals to 2x plus 1. Now do substitution for equation 1. Substituting substituting x in 1. What we get? X place will substitute 2x plus 1. X is 2x plus 1 and this plus 2 as it is. So it will be 2x plus 2 plus 1 will be 3. So fog of x will be 2x plus 3. Then we'll do GOF. What is GOF? GOF of x. That is G of f of x. What is f of x formula? We have x plus 2. So G of x plus 2. Now write down what is G of x. G of x is 2x plus 1. Call this as equation 2. Now compare this x and this x value. So x is changing to x plus 2. Now substituting substituting x in equation 2. In equation 2. So we get, that is 2 as it is. In place of x we write x plus 2. And in place of x we are substituting x plus 2 plus 1. So remove the bracket. 2 into x is 2x plus 2 2s are 4 plus 1. That will be 2x plus 2, 4 plus 1 is 5. So this is your graph of x. Hope you understood. We'll move on with the next question. So the next question is, prove that the function f from R to R defined by f of x is 2x minus 3 is bijective. What is mean by bijective? Bijective means the function should be 1 to 1, that is injective, and it should be on to surjective. If it is injective and surjective, then it is called bijective. So we have to prove it is a bijective now. So to prove bijective, we can write f of x equals 2x minus 3. So for 1 to 1, 1 to 1, let x1 comma x2 belongs to R. Then f of x1 will be equal to f of x2. What is x1? F of x? So it is 2x minus 3. 2x minus 3 equals 2x minus 3. So here we have here x1 and here x2. Then this minus 3 cancel. So we get 2x1 equals 2x2. This 2 and 2 cancel. You get x1 equals x2. Therefore, f is 1 to 1. This is how you prove it for 1 to 1. Then we'll prove what is onto. So let x belongs to R. There exists y belongs to R such that f of x is equals to y. So what is f of x? F of x equals y. So f of x is 2x minus 3 equals y. So 2x will be y. We have to convert the formula in terms of x. Minus 3 goes at the side, become plus 3. And 2x is equals to y plus 3. Then x we want. So x will be y plus 3 divided by 2. So f of y equals y plus 3 divided by 2. So here, therefore, f is onto. Since it is both, f is both 1 to 1 and onto, it is bijective. Then moving with the next question, you have, is the function f of x equals x plus 1 from the set of integer to be a set of integer is 1 1. It is a set of integer. It's a set of integer is 1 1. So we have to prove what is only 1 1. So f of x is equals to x plus 1. So let x1 comma x2 belongs to z integer. So now f of x1 equals f of x2. That is x plus 1 equals x plus 1, and here it is 1 and it is 2. Plus 1 plus 1 will cancel. X1 equals x2. X1 equals x2. Therefore, it is f is 1 to 1. Show that the function f from R to R defined by f of x is 3 minus 4x is 1 1 and onto. So here to prove this, they have given f of x is 3 minus 4x. So let x1 comma x2 belongs to R. Then f of x1 equals f of x2. The formula is 3 minus 4x equals 3 minus 4x. So here it is 1 and here it is 2. 3 and 3 cancel. You get 4x1 equals minus 4x2. Minus 4 cancel. You get x1 equals x2. Therefore, f is 1 to 1. Then for onto, let X belongs to R, there exists Y belongs to R, such that f of x equals y. So here f of x equals y, f of x is 3 minus 4x equals y. We have to convert in the form of x formula. So minus 4x equals y minus 3. So remove minus, multiply throughout by minus. 4x equals 3 minus y. We'll just multiply minus. So minus will become plus, plus will become minus. So x will be 3 minus y divided by 4, or f inverse of y equals 3 minus y divided by 4. So yeah, therefore f is on to. Then moving with the next question we have, determine the relation R in the set A 1, 2, 3, etc. till 4 defined by R is x comma y 3x minus y equals 0 is an equivalent relation or not. So here they have given that is f of x is 3x minus y. So we can write this as y equals 3x. So now just substitute the values. If x is 1, we get y is 3 into 1, that will be 3, which is present in the form. That is, we have a is from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So now we have this 3 in the answer. X and y should be in a. Then we will take x is equals to 2. We get y equals 3 into 2. 3 2s are 6. Then x is equals to 3. We get y equals 3 into 3. 3 3s are 9. So x equals 4. Then y equals 3 into 4. 3 into 4 is 12. Then we have x equals 5, then y equals 3 into 5. 3 into 5 will be 15, but we don't have 15 here, so we will not consider this. So here we have r is x comma y. If x is 1, y is 3, and if x is 2, y is 6. If x is 3, y is 9. If x is 4, y is 12, and if x is 5 is 12. This much. Now we will check reflexive. What is reflexive? Reflexive means we have to check reflexive. Reflexive means it should be same element. We don't have the same element since 1 comma 1 is does not belongs to R. It is not reflexive. We don't have 1 comma 1. Then symmetric. What is mean by symmetric? It should be reverse. A comma b equals b comma a. So now we'll check. I'll take 1 comma 3 belongs to R, but 3 comma 1 do not belongs to R. It is not symmetric. It is not symmetric. Then let me take the other one, transitive. What is transitive? Transitive means A comma B, B comma C, and A comma C. So let me take, it is I'll take 1 comma 3 belongs to R, and 3 comma 9 belongs to R. But we have to take first and last, that is 1 comma 9. 1 comma 9 does not belongs to R. Therefore it is not transitive. It is not transitive. Therefore it is not an equivalent relation. When it is called equivalent relation, if it is reflexive, symmetric, and transitive, then only it is called equivalent relation. And in this case, it is not mapping any three, therefore it is not an equivalent relation. So moving with the next question you have, let f from R to R and g from R to R is defined by f of x equals x plus 2 and g of x equals x minus 2. Find Goff and Fog. So how do you find Goff? G of x, f of x fog, that is f of means bracket g of x. F of, what is g of x formula? We have x minus 2. So write f of x now. What is f of x? It is x plus 2. Call this as equation 1. Now substituting x value. What is x here and here? Substituting x equals x minus 2 in equation 1. So what we get? If you substitute in equation 1, we get it as x minus 2 plus 2. Minus 2 and plus 2 cancel. So the value will be x. That is fog of x. Then we will take GOF. What is GOF? GOF of x. That will be g bracket of f of x. What is f of x? F of x is x plus 2. So now write g of x formula. It is x minus 2. Call this as equation 2. Now substituting x. What is x here? X is x plus 2. X equals x plus 2 in equation 2. So we get, in place of x we'll write x plus 2. X plus 2, then this minus 2 as it is. Plus and minus get cancelled. The answer will be only x. That is your GOF of x. Then moving to the next question, we have define a reflexive symmetric relation. What is reflexive and what is symmetric? So here, reflexive means a relation R on a set A is reflexive if every element is related to itself. That is, A comma A belongs to R for every A belongs to small a belongs to capital A. That is, you have A is 1, 2, 3 and R is 1, comma 1, 2, comma 2, 3, comma 3. It is reflexive because every element is related to itself. What is a symmetric relation? A relation R is symmetric if whenever A comma B belongs to R, then B comma A also should belongs to R. Then it is called as symmetric. So for example, for symmetric is 1 comma 2 and reverse of this 2 comma 1. 2 comma 3 reverse of that 3 comma 2. For every a comma b, the reverse b comma a should exist. Then only it is called as symmetric relation. Then moving with the next one, you have show that the function f of x is defined by 2x plus 5 is 1 1 and on 2. So let me take, let x1 comma x2 belongs to R. Then let x1 f of x1 equals f of x2. So here we have 2x plus 5. We can write here then 2x plus 5, 2x plus 5. Here it is 1, here it is 2. 5 and 5 cancel. 2x1 equals 2x2. 2 and 2 cancel. x1 equals x2. Therefore, you can write that. You can write f is 1, 1. 1 to 1. Therefore, f is 1 to 1. Then, for onto let x belongs to R, there exists y belongs to R such that f of x equals y. So f of x is 2x plus 5 equals y. We have to convert in the form of x formula. So 2x will be y minus 5. X will be y minus 5 divided by 2. Therefore, f inverse of y equals y minus 5 divided by 2. So yeah, therefore f is on 2. Then you have, if let f equals from R to R, g equals R to R, defined by f of x is x plus 1 and g of x is 2x minus 1, find GOF and fog. So GOF of x will be g of f of g of x. What is g of x? That is 2x minus 1. Then write formula, g of x is 2x minus 1. Call this as equation 1. Then we have to write f of x, not g of x. So write f of x, we need to write it in f of x. So yeah, Italy f of x. What is f of x? F of x is x plus 1. So now call this as 1. Compare x value, substituting x equals 2x minus 1 in equation 1. So we get here that is x is becoming 2x minus 1, x is becoming 2x minus 1 plus 1. This 1 and 1 cancel, therefore fog of x will be 2x. Then going for gof of x, that will be g bracket of f of x, that will be g of f of x is what? F of x is x plus 1. X plus 1. Now, write what is g of x formula. G of x is 2x minus 1. Call this as equation 2. Compare this x and this x. Substituting x equals x plus 1 in equation 2. So we get 2x in place of x will write 2x, x will become x plus 1 minus 1. So it will be 2x plus 2 minus 1. 2 plus 2 minus 1 will be 2x plus 1 minus 1 plus 2 minus 1 will be plus 1. So GOF is 2x plus 1.